Welcome back. In our previous episode, that is the part 1 of this series, we discussed that we have 3 types of errors: the gross error, random error, and systematic errors. What are errors? Errors are defined as the differences between the measured value or the test value and the actual reference value. That is what errors are: the difference between the test value or the measured value and the actual reference value. We discussed elaborately on gross error in our previous discussion, where we said that gross error is that error that is so big that one has no option than to start the experiment again. That means you cannot manipulate it, it's irreparable. That is for gross error. Now let's look at the differences between systematic errors and random error, or let's discuss systematic errors and random errors. Discussing systematic and random error will require us to note some key terms or terminologies. These terms are precision, bias, and accuracy. Let's take the first one: precision. Precision is defined as the degree of repeatability or reproducibility of a measurement. Scientists take different replicate measurements or take many replicate measurements for just one experiment or for just one measurement. That means they carry out the experiment more than one times. So the precision of an experiment is the degree of reproducibility or repeatability of that experimental values. The discrepancy between repeatability and reproducibility will be discussed in later time. So, having discussed precision as the degree of reproducibility or repeatability, let us discuss accuracy. Accuracy, according to the International Organization of Standardization, is defined as the closeness of agreement between the measured value and the actual reference value. The closeness of agreement between the measured value and the actual reference value is known as the accuracy of a measurement. Then the bias. Bias is defined as an obvious deviation from the actual value in a particular direction or in a particular sense. So, in order to understand this concept very well, or in order to differentiate between random and systematic errors and all the terminologies that are defined, let us take cognizance, or as a way of illustration, use the table given in the board. This is an experiment carried out by 5 students, which involves the titration of 0.1 mole of 10 millimeter sodium hydroxide and 0.1 molar solution of hydrochloric acid. So let's use this table to actually differentiate or give the discrepancy between these terminologies just defined. Now let's look at students A measurements. From the look, our actual value is 10. The actual value is 10.00. Now, if you look at students A measurement, its measurements are, you have 10.08, 10.11, 10.09, 10.10, 10.12, and 10.10. The repeatability, that means how often were you able to give repeated measurements that are very close to each other. If you see 10.08, 10.11, 10.09, 10.10, 10.12, and 10.10 are very close together. So we actually got values which are close together repeatedly. And we said that precision is the degree of reproducibility or repeatability. So you see that these values are what? Repeated. So we can say the average of them is what? 10.10. So we can say that these values are precise because we are able to repeat them within a particular range that are not far from each other. You have 10.08, 10.11, 10.09. All of them are close together. So the result is what? Is precise. Then talking about systematic error now. Systematic errors are noted by systematic error can be recognized by bias, while random errors are recognized by precision. So let us identify the systematic error here. If the actual value is 10.00, you discover that all the measurements are not scattered around 10.00, rather they are tending to one direction. And we define bias as the obvious deviation of a measured value in one direction. So you see that all of them, they are what? They differ from the actual value in one direction, and that is what? They are higher. They are all higher. 10.08 is higher than 10.0, 10.11 is higher, 10. This, all of them, they are what? Higher in one direction. So you say that the result is what? Bias. So although the results are precise, they are what? Bias. That is to say that random errors and systematic errors can occur independently of each other. An experiment may have random error and little or no systematic error, and vice versa. So let's look at B. We have 9.88, 10.14, 10.02, 9.80, 10.21, and the average is 10.01. So you see that all the measurements are not that close together. Reason being that the range of value is from, you have 9.88 to 10.21. The range is very, very what? Far afar or far off. And so it is imprecise. That means you were not able to repeat those measurements within a very close what? Interval. You see 9.88, 10.14, they are fluctuating. So this result is what? Not precise. That means imprecise. But is it biased or not? If you look at the mean value or the average is 10.01. Compare 10.01 to 10.00. It is what? Not biased. So it's unbiased. Reason being that if you look at all of them, they are scattered around the measured value. The deviation is not in one direction. It's in both directions. Some are lower, while some are what? Higher. So in a situation where you have measurements that are close to the actual value in such a way that they are scattered around, some are lower, some are higher, such results are what? Not biased. But in a situation where they are either higher or either lower, such a result is said to be biased. Let's look at student C results. Student C, you have 10.19, 9.7, 9.69, 10.05, 9.78, and 9.90. The range of values of each measurement is from 10.19 to 9.69. You see that the range is very far, and the values are what? Fluctuating, going up, down, up, down, up, down, like that. So we say that these values are not what? Precise. That means the degree of reproducibility of this value is very what? Poor. They are not precise. You measure 9.6 here, the other time you measure 10 point. So they are fluctuating. So the repeatability of these measurements are poor, and hence they are imprecise. Also looking at the mean value is 9.90. Then you have 9.78. 10.05, 9.69, 9.79, 10.19. You see that this result is also what? Bias. It is biased because the mean value is very, very what? Small compared to the what? Compared to 10.00. So this result is imprecise and at the same time it is biased. Now the next one is D. D said you have 10.04, 9.98, 10.02, 9.97 and all like that. Now if you look at the result, they are very close to each other. They are very close. The range of value is from 10.04 to 9.97. Very close. 10.04 to 9.97 is very close. So you say that the result is what? Is precise. That means the repeatability. The difference is not that much. It's precise. Is it biased? It's not biased because they are clustered around this actual value of 10.00. Now, from our explanation or from the explanation I gave earlier, I told you that when there is an obvious deviation in a particular direction, we say that such measurements are what? Biased. And you will now ask, why are we saying that student C results are biased even though they are clustered around the mean value? Now, if you look at the deviation between student C result is so large from the what? From the main value. So the measurements are what? Biased. So that is basically that is everything that we need to know for precision, bias, and random error. So random errors are recognized by bias and systematic errors are random errors are recognized by precision of the experiment, while systematic errors are recognized by the bias of the experiment. And as I've earlier said that both systematic error and random error may occur independently. They may occur independently. Now let's look at the discrepancy between the systematic error and the random error. Now let's look at the discrepancy or the differences between random error and systematic error. But before we look at that, the lack of bias is also known as the trueness of the method. The lack of bias is the trueness of the method. That is to say that the method is what? Correctly what? Applied or used. Now let's look at some of the differences between random errors and systematic error. For random error affects the precision, reproducibility or what? Repeatability. We've discussed that before, that what is used to recognize the random error is that it affects the precision, that is to say the degree of reproducibility or repeatability of what? Measurements. Why for systematic error they produce bias, measurements in which they are either too high or either too low. So that is for that. Now secondly, random error cause replicate measurements to fall on either side of true value. They cause replicate measurement to fall on either sides of the true value. That means the true value will be in the middle and all other measurements will fall in between them. That's what random errors does. While systematic errors, all the measurements are either high or what? Either low. The next thing is that random errors can be estimated using replicate measurements. You can know whether there is a random error in an experiment by trying out replicate measurement. Replicate measurement means measuring more than one time. That means measuring what? Often. Some of you must have asked yourself, why is it that while we are carrying out titration experiments, we are often told or instructed to take more than one measurement? It is to test for the what? For the random error that may be inherent in our measurements. Then for systematic error, they cannot be detected using replicate measurement. Systematic error cannot be detected using replicate measurement. Why? Because all the values will still maintain the same precedence. all of them will maintain the same precedence because something is causing it to happen like that. And one thing that can cause systematic error is faulty equipment. For example, if the equipment is not properly calibrated, or also non-proper calibration of what equipment. If the equipment is not properly calibrated, let's say there is a little error in the calibration, you use it to measure all, and that systematic error will follow all your measurements. So systematic errors cannot be detected using what? Using replicate measurement. That means measuring more than one times will not aid you to actually determine systematic error in an experiment. Then another thing is that random errors cannot be eliminated. We can only what? Minimize them. Said cannot be estimated, cannot be what? Estimated, but can be minimized by a good techniques. They cannot be what? Estimated, or they cannot be, okay, random errors cannot be eliminated, but can be minimized by using a standard technique. That is to say, you cannot completely remove random errors from an experiment, but you can minimize the effect of the random error. While systematic error can be corrected using standard method. Both of them are caused, both random and systematic errors are caused by both humans and equipment. Gross error is mostly caused by humans, but systematic errors can either be caused by both humans and equipment. So that's basically the differences between random error and systematic errors. Most analytical techniques often ask the question, or the most important question in most analytical techniques is how close the measured value is to the true value, or how far the measured value is to the true value. This is the basis for accuracy. As discussed earlier, that accuracy is defined by the International Organization of Standardization, ISO, as the closeness of agreement between the measured value and the actual reference value. Under this definition, we can say that the accuracy of a measurement is affected by both random errors and systematic errors. Reason being that the presence of random errors may make or may cause the result not to be precise. And if these results are not precise, they may not be as close to the actual value as possible. Same is applicable to the systematic errors, which may cause bias, making all the measurement to be too high. So a measurement may be precise, but not accurate. It may be biased, unbiased rather, and still not what? Accurate. Accuracy is a concept of its own, which defines the closeness or the fairness of the measured value and the actual reference value. Having discussed this, let us distinguish between reproducibility and repeatability under precision. We classify precision into two. And those tools are, we have precision we have repeatability, and we have reproducibility. Repeatability and reproducibility. What is the discrepancy between these two terms? Now, repeatability is talking about within rerun experiment or rerun measurement, within rerun measurement, within or within run measurement. while reproducibility is between run measurements. Now, of course, this may seem so awkward. What is within run measurement and what is between run measurements? Now, the repeatability of an experiment or of a measurement is that experiment that is carried out under the same condition, with the same equipment, the same environmental condition, the same reagents, and everything are the same. That one is within run experiments or within run what measurement. For instance, in the laboratory, let's say your group, you were given EDTA, ethylene diamine tetraacetate, and you were given other reagents. Then you were given the same volumetric flask, the same beaker. You use all those beakers in the same atmospheric condition, the same temperature, the same humidity. You run the experiment, and you were able to what? To give replicate measurements. And these measurements are precise or not precise. That kind of scenario is what is called what? Repeatability. That means you were able to repeat it over and over and over again. Are you getting it now? That is what repeatability is talking about. When an experiment is conducted in the same atmospheric condition, using the same reagent and the same everything, we say that the measurement got from that experiment, which are precise, are said to be what? Repeatable. While reproducibility, talking about between run experiment, that is to say, let's say 5 scientists, let's use the 5 students above. The 5 students did their experiment in different laboratory, in different town. Let's say some did theirs in Uniport, some did theirs in OAU, Obafemi Awolowo, some did theirs in Niger Delta University, some did theirs in Delta State University, and so on and so forth. Now, it should be noted that the beaker here is different from the beaker that way. The reagent may be different. Maybe this one, the one there may be more concentrated, or it has stayed for a long time. Their atmospheric condition is different. The temperature is different. The pressure is different. The humidity is what? Different. So, the ability to reproduce what you've done here that way is what is called what? The reproducibility. For instance, while carrying out analytical research, some of the research will say, we want to try to reproduce the same measurement or the same experimental values using a different sample, a different reagent, etc. For instance, in the preparation of activated carbon, you may use plantain stalk or the plantain pedicle, that is that back they hold or they cut out, to actually produce your activated carbon and characterize it for pH, etc., conductivity, etc. Now, some here may use another sample entirely, may use a coconut bark to make its activated carbon. Now, the values that you got, if you are able to give values that are close to what that person got, or if they are able to get values that are close to what you got here, such scenario will say that the experiment or the person has been able to reproduce the experimental value. So that's the difference between reproducibility and repeatability. While repeatability deals with the same, within the same environmental condition, the same reagent and the same everything, reproducibility deals with different atmospheric condition, different experiment, different reagent, etc. It should, however, be noted that the values gotten from reproducibility are usually poorer than those gotten from repeatability. So that is the difference between reproducibility and repeatability under random errors. In summary, what are we saying in essence? That the random errors are recognized by, in summary, what are we saying? That random errors are recognized by precision, while systematic errors are recognized by bias. So that is that. Let's look at some examples of these errors. We've discussed some before. The first one is complete experimental breakdown. Of course, we know that that is what? Gross error. Complete experimental breakdown is what? Gross error. Discarding of an important reagent is gross error. Mistaking an impure reagent as pure, that is gross error. You have no option than to start the experiment again. Then we have unfavorable environmental conditions / fluctuation. That is what? Random error. The humidity different. The temperature what? Varies. That is random error. You can't check. Then non-properly calibrated glassware. That is systematic errors. We have others. Now, when they are given to you, you should be able to look at them and then classify them into these three types of error: random error, gross error, and systematic error. So that's basically that for chapter 1 of this textbook. What have we discussed? We've discussed the problems that are encountered by scientists, analytical scientists, where we said there are two problems, the quantitative and the qualitative. We discussed the type of error: random, gross, systematic. We discussed how you can recognize them, and then we discuss also accuracy and other concepts. Thank you for staying to the end. Please, if you have not subscribed to this channel, make sure you subscribe, turn on the notification button so that you will be the first person to be notified in order to get the amazing benefits that we have to give out to you. Thank you for your time.